So we would like to continue looking at the review with number 14. In a certain geographic region, newspapers are classified as being published daily morning, daily evening, or weekly. Some have comic sections and some do not. The distribution is shown here. So I have a contingency table here. So what I need to do is, because I don't see a column and a row for my totals, I need to add those totals up so that I can see there are 2, 3, 4, 5 newspapers distributed in the morning. There are 7 newspapers distributed in the evening. There are 3 weekly newspapers. There are 6, because 2, 3, 1 gives me 6 newspapers that have comics. And there are 9 newspapers that do not have comics. If I add all of these values up in the original table, that gives me 15 total newspapers that I'm looking at. This helps me because now I know that this is my denominator. So what is the probability that the newspaper is a weekly publication? So the probability of it being weekly, well, that's this one. I know that there's a total of 15, and there are 3 that are weekly. So 3 divided by 15 is 0.200. You could put 0.2. That's fine as well. What is the probability that the newspaper is a daily morning or has comics? So probability that it's a morning or has comics. Well, notice that I can be morning and have comics at the same time. So that means I'm going to end up having to subtract out that overlap. So we want the probability of being morning plus the probability of having comics minus the probability of being morning and comics. So the probability of being morning is 5 out of 15. The probability of having a comics is 6 out of 15. Then the probability of being morning and comics is 2 out of 15. I add those up and divide, and I get 0.600. Now you'll notice I'm not writing sentences. That's because I have very limited space. You should be writing the sentences so that you know what you're looking at. Now then, what is the probability that the newspaper does not have a comic section and is a weekly publication? So we want probability, no comics, and that it's weekly. That's going to be basically their overlap. So no comics is here. Weekly is here, so there are 2 weekly publications with no comics. 2 divided by 15 is going to give me a 0.133. So the probability that the newspaper does not have a comic section and is a weekly publication is 0.133. What is the probability that the newspaper has a comic section? So we're looking at comics, given that it is daily evening publication. So given that it is an evening publication. That's going to be the probability of comics and evening divided by the probability of evening, that given portion. Well, the probability of comics and evening, so that'd be the yes and evening, would be 3 out of 15. So we had 3 out of 15 for the comics and evening. Then the total evening, which is here, is 7. So that's 7 out of 15. I do that division and I get 0.429. So the probability that the newspaper has a comics section, given that it is a daily evening publication, is 0.429. Let's look at another example with a contingency table. At a large factory, the employees were surveyed and classified according to their level of education and whether they attended a sports event at least once a month. The data is shown below. So I see this contingency table, but again, I do not see totals. So I'm going to take a moment and I'm going to add all of these up so that I can get some totals to look at. And so the total high school graduates is going to be 28. The total with a 2-year degree is going to be 39. The total with a 4-year degree will be 49. The total that have attended at least one sports event in the last month is going to be 60. And those that do not attend is going to be 56. This gives us a total of 116 people that we have surveyed. So we select one employee at random, find the probability that an employee attends a sports event or is a 2-year college graduate. So the probability that they attend or 2-year degree. Now they can have a 2-year degree and they can attend a sports event at the same time. So that's going to be the probability that they attend plus the probability of 2-year degree minus the probability attend and 2-year degree. So the probability that they attend is going to be 60 out of 116. The probability that they have a 2-year degree will be 39 out of 116. The probability that they attend and have a 2-year degree, well, that's here in this overlap, so that's 20 out of 116. We do the addition, subtraction, and division, and we come up with the probability that an employee attends sports events or is a 2-year college graduate is 0.681. Given that the employee has a high school graduate, so the probability we're going to have given high school, find the probability that he or she does not attend. So not attend. So since this is a given, we're going to have the probability of not attend and high school graduate divided by the probability of a high school graduate. So the probability that they are a high school graduate and do not attend will be 12 out of 116. The probability that they're a high school graduate will be 28 out of 116. Do the division, and we should get 0.429. So the probability that the employee does not attend sports events, given that the employee is a high school graduate, is 0.429. Now these are things on both of these contingency tables. These are items that can happen at the exact same time. They are two characteristics of the same thing. So in other words, being a morning paper and having a comic section is talking about the exact same newspaper. Attending a sports event and being a high school graduate is talking about characteristics of the exact same employee. Now in number 16, it says we want to draw 2 cards out of a standard deck without replacement. So we're drawing the first card, then we're drawing a second card. We want to find the probability of 2 jacks. What this is saying is I want the probability of a jack on the first and the probability of a jack on the second. But we have to remember that this was without replacement. So there are 4 jacks in a deck of cards out of 52. This is my first card. My second card, I did not replace this particular one, and I'm wanting it to be a jack. So now there are only 3 jacks left in the deck of cards out of 51. This is whenever it is looking at without replacement. We decrease our denominators. Okay? So we do the multiplication and the division, and we get that the probability of drawing 2 jacks without replacement is going to be 0.005. Now let's look at the probability of drawing 2 red cards. This is the probability of getting a red and the probability of getting a second red. There are 26 red cards in a deck of cards. Well, I did not replace the first card that I drew, and I'm going to assume that it is a red card. So that leaves me with 25 red cards out of 51 total cards left. I'm going to do this multiplication and division, and we get 0.245. So the probability of drawing 2 red cards without replacement is going to be 0.245. Number 17. A marathon race has 65 contestants. That's my N. In how many ways could these runners finish in first, second, third, fourth, and fifth? So we have 5 places that we're looking at. Our biggest challenge is to determine if this is a permutation or a combination, because we're looking at how many ways. Well, because we have given it an order, first, second, third, fourth, fifth, this is going to be a permutation. We have 65 contestants total, and we have 1, 2, 3, 4, 5 places that we're looking at. So we have 65P5. This becomes a really large number. You can do it in your calculator, you can do it out with the formula, either way. But what happens is we come out with 991,186,560 ways that these 65 runners can finish the race in the top 5. So 65 contestants have 991,186,560 ways to finish first, second, third, fourth, and fifth. Again, 65 contestants have 991,186,560 ways to finish first, second, third, fourth, and fifth place. White copy paper is offered in 5 different strengths. So we have strengths, we have 5, and 11 different degrees of brightness. We have brightness, there's 11. It's recycled or not. So recycled, there are 2 ways, because it's recycled or not. also an acid-free or not. Acid-free, there are two possibilities. We want to know how many different types of paper are available to order. So in this case, we're selecting one from each category. Anytime that we select one from each category, recall, we're going to be multiplying. When we multiply this, we're going to have 5 times 11 times 2 times 2, which gives us 220. White copy paper comes in 220 different types. Because we have different strengths, we have different brightnesses, and each time that we change one item, it gives us a different type of copy paper. Number 19. In how many ways can 5 cellular phones be selected from 8 cellular phones? We want to select 5 from the 8. Now when we're selecting 5 from 8, it is not specified if there's an order or not. So we're going to assume that there's no order because we're just wanting 5 of these cellular phones. So that means that we have 8 total phones. We're going to look for combinations of 5. 8C5. Now again, you can work this by hand. You can work it in your calculator, either way. We should end up with 56. There are 56 ways 5 cellular phones can be selected from 8 cellular phones. There are 56 ways 5 cellular phones can be selected from 8 cellular phones. The last question on this is, what is the sample space if you toss 2 coins? I'm going to draw a tree diagram to kind of remind you how a tree diagram goes. But we have our first toss and we have our second toss. The first toss can be a head or it can be a tail. The second toss, it doesn't matter if it's a head or a tail on the first one. So it can also be a head or a tail. A head or a tail. So my sample space is I'm going to follow the branches. I get a head and a head. Then I get a head and a tail. Then I could get a tail, head, or I could get a tail and tail. So here's my sample space. Now these 2 middle ones, we're looking at order because we're looking at the first coin and then the second coin. If a question asks for what's the probability that you toss 1 head and 1 tail, you would include both of these. It depends on if it's wanting the order or not. But any sample space where you're doing 2, 3, 4 items, recall that the order is going to matter there. So make sure that you practice on these and then let me know if you have any questions.